Today we're taking a look at uniform circular motion. What is uniform circular motion? It's the constant motion of an object on a circular path. The motion has a constant speed but changing velocity. Now if you remember the difference between speed and velocity, speed only has magnitude, velocity has direction. So the speed is constant because it's going a certain meters per second all the time. But the reason why the velocity is changing is because it's changing direction. Not magnitude, but direction. As you can see here, we have an object moving around in a circle. The velocity, which is the blue arrow, is changing direction, but it's not changing magnitude. And if you take away that red line, which is the force trying to keep the object in the circular path, then it will continue to move in that direction. So if there's a change in velocity, there must be acceleration. This is called centripetal acceleration, and it always points towards the center. So if a mass is being accelerated, there must be a force. This force is called centripetal force. And once you remove that force, the object wants to move tangent to whatever path it was going. Here's another example of cutting what's providing the centripetal force. As you can see, if you're just doing that in the air without any other constraints, when you cut it, it initially goes tangent to the motion, but then because it's in air, projectile motion comes into play and it starts curving downward. Alright, now we're going to take a look at centripetal force, which is basically the chain that was holding that rock in that circular path. And that centripetal force can come in many different ways. It can be a tension, like a string or a rope or something like that. It could be friction on a road when you're turning your car. The friction is what keeps the car from going in a straight line. Or it could also be gravity, like the moon rotating around the earth, or the earth rotating around the sun. So however that force is provided, the centripetal force will be equal to mass times velocity squared over r, where Fc is centripetal force, m is mass, v is velocity, r is radius or distance from the center. So centripetal acceleration is pretty much the same thing without the m. You have to remember F is equal to ma. So if A centripetal is v squared over r, then centripetal force would just be mv squared over r. That's the only difference. So here's an example. A roller coaster car is traveling at a constant speed over a hill with a curvature radius of 69 meters. What is the maximum velocity the car can travel at the top of the hill and stay on the track if its only acceleration is due to gravity? So what does this mean for us? Well, if our only acceleration is due to gravity, then that would be my centripetal acceleration. That's what's keeping the roller coaster on the track. So that means that my acceleration due to gravity is my centripetal acceleration, which is v squared over r. Now since we have r, and we technically have AC, we can solve for v. So we get 9.8 equals v squared over 69. Multiply both sides by 69 and we get 676.2 equals v squared. And then in order to get V by itself, we have to take the square root. So that means V is approximately 26 meters per second. Here's another example. 65 kilogram student is on an amusement park ride. That ride spins the student in a horizontal circle at a constant speed of 9 meters per second. The floor is lowered and the student remains against the wall without falling to the floor. What is the radius of the ride if centripetal acceleration acting on the student is 4.0 meters per second squared? Now, we have acceleration and we have speed and we're looking for R. Since it says nothing about force, that 65 kilogram part is not really needed. We can use centripetal acceleration equals V squared over R. Now you could add the M to both sides, you could find the centripetal force and then use mv squared over R, but you'll get the same answer, you don't really need it. So I end up with 4 equals 9 squared over R. So that means we need to, I don't know if you guys remember butterfly method from math, but basically we need to multiply both sides by R and then divide both sides by 4. So they kind of switch places. Then that gives me R is equal to 20.25 meters per second. Here is our last example. A 0.5 kilogram ball attached to a string is rotating in a horizontal circle of radius 0.75 meters. Assume the tension force is directed horizontally. If it takes the ball 0.5 seconds to revolve, what is the tension Fc in the string? So let's remember that Fc, which is what we're looking for, is equal to mv squared over R. We have velocity indirectly. Here's why we have velocity. Velocity is distance over time. Well, they gave us a radius, which means we have the distance of one revolution, and they give us the time for that revolution, so we have time also. So in order to get velocity, which is distance over time, we'll get the circumference, which is 2 pi r, and divide that by t, which is the time in seconds. So this gives us about 9.4. R is 0.75 and the time is 0.5, so you just plug it in the equation. So let's get back over to force, because now we have V, M, and R. So the centripetal force will be equal to M, which is again 0.5, times V 9.4 squared, divided by R, which is 0.75. So my centripetal force is equal to 58.9. That's it.